Breaking space news, we just got new evidence for the gravitational wave background from a pulsar timing array. And if that sounded like gibberish, let me break it down for you. Gravitational waves are ripples through the fabric of space itself caused by accelerating mass. So this just created a gravitational wave. But the gravitational waves coming from cats are really difficult to detect, so we have to turn to big astrophysical sources. This could be stuff like colliding neutron stars or merging black holes. But beyond the gravitational waves caused by these isolated events, we also think that there is a gravitational wave background, a kind of steady hum throughout the universe. This would come from a myriad of sources, maybe orbiting black hole binaries in a whole bunch of different galaxies, or even from early universe physics, stuff from before the first stars were even formed. Detecting this gravitational wave background is difficult because it has much lower energies than the waves coming from, say, a neutron star collision. So we can't build any experiments on Earth like LIGO to detect it. Instead, over the past couple of years, we've started to see the use of pulsar timing arrays. Pulsars are rapidly spinning neutron stars that are shooting jets of radiation out of their poles. When those jets become aligned with us, we get flashes of light at very regular intervals. The idea behind a pulsar timing array is we look at a whole bunch of pulsars across the galaxy and measure changes in the arrival time of those flashes. Gravitational waves will slightly change the distance between us and the pulsar and thus slightly change the arrival time of the pulsar's signals. Last year, several different collaborations announced evidence for a gravitational wave background from these pulsar timing arrays. And today, we got the results from another collaboration that used MeerKAT, an array of radio telescopes in South Africa. They observed 83 pulsars over 4.5 years and found a signal indicative of a gravitational wave background. But we can't quite call this or any of the pulsar timing results a detection. This signal is buried in a whole bunch of other crap, changes in the pulsar's behavior, interactions with material in between us and the pulsar, noise from the telescope, the solar wind, and depending on different models for the noise, the significance of this observation changes a lot. But the fact that they found this, and it's roughly in line with what we saw in other independent observations last year, is really amazing. With these results, they were even able to map out the power of the gravitational wave background across the sky. We would expect it to be pretty much constant wherever you looked, but that's not what they found. Although the variations could just be statistical fluctuations, this is definitely something to keep an eye on. It's really an exciting time for gravitational wave science. As we get more and more observations of the pulsars and better models for the noise, we're going to start to understand the universe in a whole new way.